So many of us attempted the assignment now. The Python crash course assignment and the NumPy assignment. How many of us have attempted it? I'm not getting any response from us. But then if we don't attempt those assignments, it just look like we are wasting our time in this class, because the only way I know you understand, and the only way to prove yourself you understand what I did, is by you attempting the assignment and you submitting, so I will know this is what I'm doing wrong, this is what I'm doing right. I know how to correct myself. Sorry. So please, let's always attempt the assignments. I've seen only Python crash course assignment. I've not seen any NumPy assignments thus far. So please, let's do that before the next class, so that we'll be able to know, okay, if we did the analysis stream well, before we move into the data visualization, then move into machine learning. And hope we are getting everything we are explaining in this class. Hope we are getting what we are explaining in this class. This no response thing, I don't understand again. Someone please say something now. Okay, welcome, Aki. Let me up. Let me just share my screen so that we can just start straight. Okay, just share my. Oh, we can all see my screen. Hope we can see my screen now. I will assume we can all see my screen, because someone is trying to talk, but then network is probably bad or something. So we are already live on YouTube, as you can see on your screen. Yeah, so let's get to it. So in this section of the course, we will learn how to use Pandas for data analysis. We think of Pandas as extremely powerful version of Excel with a lot of more features. In this section of the course, should go through notebook in this order. Introduction to Pandas, which is this one. We are going to series, data frame, missing data, go by, merging, joining, and concatenation, operations, data input and output. So we are moving straight to series. So let me just clear my kernel. So, okay, let's get started then. So the first main type we will learn about for Pandas is series data type. Let's import Pandas, explore series objects. A series is very similar to the NumPy array. In fact, it is built on top of NumPy array objects. We differentiate NumPy array from series. I mean, the difference between NumPy array and series is that a series can have axis label, meaning it can be indexed by a label instead of just number location. It also doesn't need to hold numerical data. It can hold any arbitrary Python object. When we're doing array, we're only able to use numbers. But then in series, we can hold strings, we can hold lists, and other things like that. Hope we are getting me. Wait. Hope we are getting what I'm saying.
Yes, sir.
I'll just go on assuming you guys are getting what I'm saying. So we imported NumPy and Pandas. So here we created a list called ABC, a list called label, created another list called my list, created a NumPy array, and we created a dictionary. So here are the 4 of them. So we have a list, my list, which is another list. Then we have a NumPy array, and we have a dictionary, a Python dictionary. So here we are converting a list. We are converting a list into a series. So you can see what happened there. It's converted into a series. Then here we are converting a list. And you can see what we have here is the normal indexing that we normally have in NumPy. That's what we used to call them in NumPy array. Position 0, position 1, position 2. But then you can now set your own label. So you say index equals label. Whatever you put in your label list here, you can call your label list anything you like though. So whatever you have there, you can easily have here. So you can see instead of 0, 1, 2, 3 here, we have ABC as our labels. So we are, instead of we having my data equals this, then index equals this, you can just arrange them in this order. So you have your data that you want to put in there, then you have what you want to use to index that second thing. So that's what we have here. You can see it's still the same thing. Then we have converting an array into a series. You just call pd.series on it, and it converts into a series. Then you can have labels too for array like that. Then we have dictionary. So dictionary, dictionary is normally key value pair. So the key will become the index, and the value will become the data. So that's what will happen here. So you can see what's happening here now. Then we have data in series. So this series, so we are converting our label to the data now. So it's not like once you call something label, you can use it as data. That's what I'm trying to prove here. Then we can have Python functions in our series. So that's what we have here. We have built-in Python function for sum. We have built-in Python function for print. We have built-in Python function for length. So that's that. Then we have using an index. The key to using a series is understanding its index. Pandas makes use of this index name or number by allowing a fast lookup of information works like a hash table or a dictionary. So basically what we are saying here is using key. The key is using series to understand index, like the key using series to understand index. So this is our index here, and this is our data here. So we run this now. You can see our series 1, then here's our series 2. So this is what our series 2 looks like. So 1, 2, 3, 4, 1, 2, 3, 4. You can see USA, Germany, USSR, Japan. Then here we have USA, Germany, Italy, Japan. So moving on from there, we can call out our USA now. You can see our USA is 1 for series 1. But then we say series 1 plus series 2. No, series 1 and series 2, we have USA in common, we have Germany in common. Italy is not common to the two of them, but then the USS actually is not common to the two of them. We have Japan, which is common to them too. So we add the two of them together. You see what happens? Italy is not a number because there's Italy here. There's Italy here, but not here. So Italy is not a number. Then USSR too is not a number because there's USSR here, but then it's not here. That's why I say it's not a number. But then those ones that have their index in common, that's where you can add them. And you remember when we're doing series and when we're doing lists, when we add two lists together, if we add them on the index, so our index here is what is adding on. So where the index is not common, it's saying not a number. Do we get it? Any questions so far? Someone should see something now, even if it's just to write something. If there's any question, you get what I've just done, so I can move to the next notebook. Okay, no question, no question. Okay, thank you very much for that swift response. Okay, moving on from there now. We are moving to data frame. We've done series here now. We are on to do data frame. Data frame is more like the Excel table that we normally work with. So I will explain it here now. Data frame is the workhorse of Pandas and are directly inspired by the R programming language. We can think of data frame as a bunch of series objects put together to share the same index. Let's use Pandas to explore this topic. So basically what this one is saying is data frame is just a combination of different series. Series has just two colons. The index, just one colon. It has the index and a colon. But then in data frame, we can have multiple colons. The way our Excel works. So import our our pandas and numpy here. Then we import random numbers. That's natural, normal distribution random numbers from the random numpy array. Then we set seed. This seed that we are setting here is for uniformity. So any number I generate on my own end will be the same as the number you generate on your own end. If we use the same seed. So if I change my seed is 101, if I change my seed to 10, and your seed is 10, we generate the same number. But the number we generate when my seed is 10 will be different with the number I generate when my seed is 101. But then if we don't set any seed, numbers we generate will be different from each other. So that's why I'm setting a seed there. So data frame now, I'm generating a random number, a set of random numbers. I'm generating 5 rows, 4 columns. Then the index, now I'm not calling the index A, B, C, D, E. We have 5 rows, so that's 5 A, B, C, D, E. I'm splitting it. If you remember when we're splitting, what's it called now? When we're splitting, I can't remember. When we're splitting strings. So when we're splitting strings, so we split by space. So that's what we're doing here. We're just capitalizing on that knowledge here. Then here, the number of colons, we have 4 colons. That's why we're W, X, Y, Z, and we are splitting them too. So we run this now, and we'll check our data frame. You can see A, B, C, D, E, W, X, Y, Z. So you can see this one looks like your Excel table. So now we can call our colons by their by the colon name. So here we are calling W. So W will give you just all this. Then we call W and Z. That will give you W and Z. So we call that and that. So to give you just W and Z, you can see what it looks like. Then we can call df.w. So we can just use, instead of this square bracket now, you can just do df.w. But then this will only majorly work when there's no space between your column name. So here we are checking for data type of W. You can see it's a series. That's what I was saying when I was running data frame the other time, like it's a combination of different series together. So you can see just one column is a series. But then we can form a new column. Call it, for example, this is a new column we are forming now. So we have dfw plus dfy. So when we run this, you can see our df now. You can see we have a new column called df new. So that's our new. Here we have wxyz, the normal ones we have. Then the new one we just generated. Then we can drop a column. In list, we are using pop. So here we are dropping a column, but then we have to set the axis to be 0. To be 1, because by default the axis is 0, and the axis being 0 means we want to remove a row. But here we want to remove a colon. So that's what we are dropping a colon there. We are dropping new. That's what we told it to do. So then we are now saying, okay, but because we did not put in place now, because we not put in place here, it just dropped it here. It's not actually expressing it now. It's not actually saving it in our memory. But if we now put in place here, in place equals true. So by the time we now drop it here and we now call our df, you can see it has actually removed it totally. So it's no more in our memory. So if you want to drop a colon, then you have to put it in place. But then if you want to drop a row, axis equals 0, or you might not necessarily need to put axis again, because by default it is 0. So we drop a row here. You can see that's the row. Then we have location. That's our A. So we are just printing our A. That's our row. So if you want to call your row now, use location. Then we use iLoc. That's index location. So instead of using your ABC that you are using here, you can use the index. That's why we call it iLoc. So index location. So you can just see 0, just look in your head, 0, 1, 2. So this is where it will print for us now. So we run this. You can see that's what it printed for us, -2, 0.47, and the likes like that. So moving on from there, we have subsetting. So we can just subset the locations B and Y. So that's B and Y, BY. So we run this now. You can see that's BY, BY. So this is what it will print for us. You are getting like that. Then we have AB and WY. So that's ABWY. That's ABWY. So to give you these two here and these two here. Hope we are getting it. So I won't be talking into the air. Hope you are getting it. Please, someone just respond on the chat box or say something.
Yes, sir.
Okay, thank you very much. So then we have our df. This is our data frame again here. We did not put in place equals to when we're removing our e the other time. That was why this is still here now. So we call our df greater than 0 now. You can see it's giving us true wherever is greater than 0 and giving us false wherever is less than 0. So we now put our that's inside a square bracket here. Remember we did it same thing in NumPy when we're doing NumPy. When we want to just call out some conditional rules from our data sets. So we run this now. You can see it's putting out a number to those places where they are false, and actually putting the numbers to where they are true. But then if a O row is false, to remove that O row instead of adding out the number everywhere, to remove that O row, or if a O column is false, to remove that O column. So we have DF where W greater than 0 now. You can see it just removed row C where it is less than 0. It remove it. That's where you can see what we have the condition here. So we are calling by W, but then we are calling on the whole thing. So it just removed this whole row like this because W is less than 0 here. So that's why I removed the whole thing. That's what we are having here. Then we are now saying where W is greater than 0, then give us only Y. That's what we are saying here. So we now run this. You can see it's giving us just Y alone. And that's where W is greater than 0. But then we said where W is greater than 0, give us Y and X. So give us where W is greater than 0, Y and X now. So that's X and Y. Then we have this DFW greater than 0 and DFY greater than 1. So that's the only place where W is greater than 0 and Y greater than 1. If you remember when I was teaching us logic, remember what AND does? It's only where the two both are true that to give us. I didn't use OR here. That's where we use pipe. We run this to give us where either of them is true. So let me just change it back to AND now. Let me change it back to AND. So that's what we are having here. Sorry, let me quickly respond to this. Someone is stopping me here. Let me just. Sorry. So moving on from there now. So here we have data frame. That's the data frame. Then we have reset index. If we reset our index, it will turn our index that we have here, all this index, that's ABCD. It turn it into a colon. They now give us our normal number index. That's 0, 1, 2, 3, 4 here. So that's what we have here. Now you can see it turn our actual index into a colon. They now give us 0, 1, 2, 3, 4. Then here is under number. Under this thing we have here. We will split on space like that. So we have Canada, New York, West York. I don't understand Oregon. Then I don't know what this CO means again. Then our state, we call our state new wine. So DF. Then we have our state here. You can see we have our state as a new colon here. Then we can set index. That is, we set our state to be the new index for this thing here. So we set the index now. You can see state is now an index instead of the actual index that we used to have. So state became our index, and our index now have a colon name. Then we call our DF now. You can see, but we not put in place. So our state is not yet stored in the memory as the index. So now we put in place equals true, and we run DF this, and it's giving us the right response. So do we get to this point? Any questions so far? Any questions so far? Every other name fade away. Jesus, take your place. Every other name fade away. No response now. Please, someone should just say something. You guys get to this point, just say no question or we get it or something, so I can continue. Some people will still later watch this thing online. So just put yourself in their shoes. Whatever you don't get so far or something that is looking shady, just ask the question now so we can deal with it before we move on. Nobody's responding. Okay, no question. Thank you very much. So let's move on. So here we are doing multi-index, that is index hierarchy. That is, we want to have more than one index. We have just one index here. We have just one index here, but here we want to have index hierarchy. So here we have outside. We call a list outside. That's G1, G1, G1. G2, G2, G2. Then we have inside 1, 2, 3, 1, 2, 3. Then we now have our higher index. That's we want to zip our this and this together. So we are zipping them together and making it into a list. That's what we did there. Then we now say higher index PD multi-index from tuple higher index. So we are just making multi-index from here. So we call this now. You can see that's we've done when we zip them together and do all this, all that we've done each of them into a tuple. So from tuple, that we just did there. So here now we are now checking a set of random numbers. So we have random numbers. We are checking. So we are checking. We are creating a 6-row 2 set of random numbers from the random normal distribution. So we have index, higher index, then our colon is AB. So we give our colon name AB, then we are now giving our index to be higher index. And remember our higher index it has 2 things there. So we have multiple index there like that. So we run this now, you can see we have G1, G1, G1. That's where we have G1, G1, G1 here. So we have just one G1, but then you can see that blue highlights it down. Then this G2 too, the blue highlights it down. Then we have 1, 2, 3, 1, 2, 3. Are you getting it? I will assume we said yes. So now let's show how to index this. For index hierarchy, we use df location. If this was on the column axis, we would just use normal brackets. That's this. Then calling one level of the hierarchy returns is sub-data frame. So we are calling location because we are calling the X from on the row now. We are now calling G1. If you know what G1 will just give us everything that is here like this. So that's what location G1 will give us. So you can see what it's giving us. It's giving us exactly what I just said it will give us. Then we have location G1, location 1. So location G1 will give us here, everything here. Then we have location 1. So location 1 will now give us this. So that's what it will give us here. So we run this now. So you can see that's what it's giving us. Then we have index names, index.names. So it will give us the names of our indexes. But then our index don't have names. So it will give us none. You can see none, none. But here now we are now setting index name. You know, when we're doing this, when we're doing here, there was no index name. But then when we got here, we have our index name to the state. So we are now setting index name here too. So that's what we are doing here. So these are our index names here too. So we set our index name to be group and number. So whenever we check our DF now, we have group and number. Then we have here, we are just calling the same thing that we called there. So we are now having just calling G1. So we are calling XS to call our axis G1. Then we are now calling G11. You know, this one is easier than when we're using just location. You know, when we're using location, we have to use location, then dot location again to call G1 and 1. But then when we got here, we just use XS and just G1. So we have that. So you can see it's saying it's going to remove in the future. So then we say we should XS is deprecated and will be removed in the future version. So in future, this our XS might not work again. So we can always revert back to your location. But then it's still working for now, so we can use it. But then we can now call our 1, then we say level equals number. No, normally we say level equals 0 or 1 before. But here, because our colon has names, so we can say level equals number. So we call this now to just give us where the level equals number. So if you notice here, we are calling 1. So it will just give you G1 and G2 because they both have 1 as the number in common there. So give you 0, 3, 1, 169, then 0, 1, 6, 6, and 0, 8, 4. And that's what it's giving us here. Do we get it? Do we all get it?
Yes, sir.
Okay, thank you very much. So I just came to check if there was any question on YouTube, because someone accused me of not responding to it on YouTube the last time, and it seems there's no question. Yeah, so let's just move on to what we're doing. So now we are going to missing data. Is there any question there? No. So we are going to missing data now. So missing data, what do I mean by missing data? Missing data is just, how do I put it now? It's just a way of, okay, you know, when we said false the other time, let me go back to this place, our data frame actually. Let's go back to our data frame. When we're doing that, this thing here, when we're doing conditional selection, we had some place that were not a number. That's where, So that's where we have missing data. This is like a missing data now. So we don't know what is there, even though we know what was there here. So how to fix that if your data came like this, without you having a prior knowledge of it being like this. For example, let me just explain where missing data gets into our data. You know, when how many of us have people that have attended the university will actually understand saying, like when they are doing research, they would distribute questionnaires. Then there are some questions that might be a bit sensitive that our respondents don't want to fill. But then when we are now inputting data to the system, we'll leave those places blank. So that's a way by which missing data is introduced into our data. Or when the information the person is giving is wrong. For example, let's say a 2-year-old baby. Well, a 2-year-old baby can be earning ₦1 billion, but then a 2-year-old baby earn ₦1 billion, or an outlier, and we can see an outlier as a problem too that we want to fix. So this is how to fix them here. So here we have NumPy and Pandas. We are importing them. Then we created our data frame. So we check our data frame now. We have some missing data. We have a missing data here, missing data there, missing data here. The first way to deal with the missing data is just to throw away the whole questionnaire. That is when there is a missing data in your questionnaire. That is, if you don't fill all the information needed, I'll just throw away your questionnaire. I won't fill it into the computer at all. Or the data scientist just remove the whole questionnaire for that particular person off. So this is how to do that one. So we drop NA. You can see there's NA here, so you drop the whole row. So this is one person's questionnaire, this is another person's questionnaire. So you drop the whole row like that. Then we can drop the whole column too. If there is too much missing data in the column, so we can see we have the column here. But then we can set a threshold. That is, whenever the number of missing data is greater than or equal to 2, drop those rows that have that. That is, the number of missing data is greater than or equal to 2. And that's why we can see how this row with just one missing data. Then we can fill our values. We don't put in place equals to here, so our data will still remain the same. Then we can fill our values. So if we fill our value here, you can see what it's giving us. So we are filling our value here. So we are replacing the missing data with fill value. But then you can replace it with the mean. For example, here I found the mean here. Then I'm now replacing with value equals df.a mean. That is to find the mean of a colon. This is how to find the mean of a colon. So then I'm now filling the missing data with that. So you can see where we are, that column that we found fill the missing data now. Here we have, that's A. We have A 1 and 2. 1 and 2, then we add 1 and 2 together. You're going to find me now, we just sum them together and divide by the number of variables we have. So we have 1 plus 2, which is 3. Then 3 divided by 2, that's 1.5. That was how we got this 1.5 to fill our missing data here. Do we get it? There are actually other ways of imputing missing data, but then this the function you would use. But what you now use to replace your missing data, maybe your median, your mode, or something else that you've calculated or you got from your research. But then this is how to use fill NA to fill our missing data. Any questions so far? Any questions so far before I move to goodbye? Any questions so far? Someone just write in the chat board like there's no question or something. Okay, no question. Hope you understand what I'm. So here is under kernel. So here is just how to go by. For example, if you've done pivot table in Excel, you understand what this go by will do for us more. So here we are creating our companies. We have Google, we have Microsoft, we have Facebook. Then we have person, we have Sam, we have Charlie, we have Amy, we have Vanessa, we have Carl, we have Sarah. Then the sales each of them made. I think I cleared the kernel. Clear all out. So I've done that. So let me just run this. So I created my data frame. Okay, that's this is it here. We have our companies, this Google, this Microsoft, this Facebook. Then we have Sam, the name of the salesperson they have, and the sales amount of sales each of them made. So now we can use the group by method to group by rows together based off of column name. For instance, let's group by company. This will create data frame group by object. So we can group by company. So we can have Google separate, Microsoft and Facebook. So we can easily find the mean of the particular group, maybe the mean of Google alone, the mean of Microsoft alone, or the mean of Facebook alone. So here is the group by. but we can't really see what it's doing. That's why it's giving us pandas go by generic data frame go by object, and it's telling you the location where it's saved on your system, on your memory. Then we have go by company again. So we now give it a name. That's by company. So we now say mean. So this finding by company, the mean now, find the mean for Google, mean for Microsoft, and mean for Facebook. So you can see it's a very, very handy thing for us to use. Then we can find the, instead of we having to name it first, then we find the mean, then we can just do all that at once. And that we just did here. Then we can find the standard deviation by company, the minimum by company. So you can see, for example, the minimum for each company. Now you can see, for example, let's say you want to fire some of your staff. Let's say your company is looking like, oh, we can actually do away with 30% of our staffs. Then you now want to like fire one person from each division. So you can just look for persons making the minimum sales. So you can see the minimum here. Carl is the minimum for Facebook. Google is the minimum for, Charlie is the minimum for Google, and Amy is the minimum for Microsoft. So you can find the minimum for each department. So your own will not be companies again, it will be departments. Then you can find the maximum for each department. So maybe you want to reward or promote some people, then you can find the maximum. You can find the count for each company. We have two persons and two sales for each company. You can describe by company. So you can see that this describe actually gives us everything we need. We have the count, we have the mean, we have standard deviation, we have the mean, minimum, we have the 25th percentile, the 50th percentile, the 70th percentile, and the maximum. I'm expecting us to ask me a question on this 25th percentile, 50th percentile, and 70th percentile. But if you guys don't ask any question, I'll just move on from there. Then here we'll just transpose what we have there. We know, if you don't make this before, you understand what I mean by transpose. It's something like we just tilted this thing, and that's what we have here. You can see we now tilted it. Then we have our sales and everything here. Then we have our company, and that's Facebook, Microsoft, and Google here. Then we have our describe, and we not just want to pick for Google alone, and that we just did here. So any questions so far before we move to the next notebook? Any questions so far?
No questions, sir.
Okay. So let's move on then to, what's it called now? Let's move on to merging, joining, and concatenation. So what do I mean by merging, joining, and concatenation? It's just a way by which we join more than one data set together. Like if we have more than one data frame, then we can easily join them together. So how do we do that? That's what I want to teach us here. So here we have our pandas data. We are importing our pandas. Then we are creating our data frame here. Why is not just clearing my kernel for me? My system is a bit slow. I've not shut down in this. So then now here we create our first data frame. We created our second data frame. We created our third data frame. Then we are now checking our first data frame. Here, this is our first data frame. And this is our second data frame. And this is our third data frame. But then if we concatenate, it's just going to stack them on top of each other based off of the column names and then based off of the indexes. So you now stack the first 4 rows on top of the second 4 rows on top of the fourth 4 rows. And that's what we have here. So if you concatenate, that's what you're just going to do for us. You can see how I concatenated all of them on top of each other. But then the column name needs to match one another. Then here's another one. You can see we join them based off of the column. That's why we said axis 1. Yeah, because we did not set axis, the axis by default axis 0, and that's on our row. But then we want to join them off of our axis 1, which is our columns. So we can have more than one variable name for our column. So we have ABCD, ABCD, ABCD. But then our index needs to match. So that's why we have missing data here, we have missing data here, and we have missing data here too. So you can see it has to join under this 3 now, because 4, 5, 6, 7. And that's why we have ABCD like this one, then we have this one like that. So moving on from there. So that's where the introduction of missing data comes in. Then here we created another data frame, left and right. So here's our left and this is our right. You can see we have A, B, and C, D. We have keys here. We have key 0, key 1, key 2, key 3. And we have keys here, key 0, key 1, key 2, key 3. So if we merge our data now, we are merging left and right together. So we are doing inner merge on our keys. So to check the keys, to combine the keys, now it says key 0, key 1, key 2, key 3. So to now join them. And that's what the merging is doing here. So if you do the joining here, you can see how it joined them. So you now join A, B, C, D. So we have our keys. Since our keys is the same, That's why we have the common colon to them is keys. That's why we said how on keys. So we are saying on keys now. So it's just joining based off of this key. So if we have, for example, if I have key 4 here, if I have key 4 here instead of key 3, and I run this, and I run this, then I come back to run this, it introduce a missing data set, a missing row for me. You can see it removed 2 rows like that are not matching. That's key 3 and key 3. Key 3 and key 4, Jerry, is removing them because they do not match one another. But then the ones that match, it brought them for me. So instead of introducing missing data now, you just remove the two of them, because if the whole row is missing, then there's no use for it. That's the consensus there. So let me just come back here and change it back to 3 back. So we have the right notebook that we add there. So when I'm uploading to GitHub, we'll be able to have the correct thing. So here is another data frame that we've created. We have right and left. So we have left and we have right. So this left, that's key 0, key 2, AB. So we have K0, K0, K1, K2, K0, K1, K0, K1. Then we have the same thing here, K0, K1, K1, K2. So like that. Then we now want to merge left and right on key 1 and key 2. So we merge the two of them like this. You can see what we are having. We have, when we merge them on key 1 and key 2, the places where they don't have anything in common. Suppose to introduce not a number there that is missing data, but then the whole row is missing. So just remove this. So that's why we have key 0, key 1, key 1. You can see we have key 0 here, we have key 0 here, we have key 1 here, we have key 1 here, like that. So that's where the introduction of key 1 comes in. Then we can see our key 0, key 0, key 0 here, and we have key 0, key 0. Then we have 3 of them here. You can see this is the actual thing we have printed out, but then we have this one and we have this one. So that's what we are having here. So are we getting? Hope we are getting it. If you don't get so far, raise up your hand or ask a question before I move on. You know, this one is on this. Then we are doing outer joining here. When we did outer joining, see it joined and brought in the missing data. You can see it's bringing the missing data here now. So this one is more robust, but then it will introduce missing data. So to bring all the rows by force, to bring all of them in and have the missing data here like that. So here's the missing data, here's another missing data, here's another missing data like that. So to bring all of them by force, bring all of them in so that they can work together. Then here we have another one on the right. This is right joining, but then it just picks the one in common. At least one of the keys must be in common. That was where it's introducing this. So you can see key 2 is common to the two. Where is it now? Key 2 is common to the two of them. So that's why it was able to introduce not a number for the other one where there was no key 0 for it. So moving on from there, then we have merge left and right. Then out on left. So if you say on left now, you can see it's bringing everything in the left and the right by force, then introducing missing data on the left now. So that's what this one is giving us here. And if you notice when we did on right, out on right here, it's giving us everything on the left. So introducing missing data on the right. So moving on from there, then we have joining. So here is our data set. Then we join on the right. So we join on the right, we introduce missing data on the left. So we join on the right. So this is our right here. So that's CD. So you can see it's introducing missing data on the right here. So we have only CD and we have just this thing CD, C0, C0, C2, CD2. That's C0, C0, CD2, D2. But then you see this one, we have, and you see our indexes, we have K0, K1, K2. Here we have K0, K2, K3. But since we are joining on right now, it will bring in all the indexes of the left. So these are all the indexes of the left. That's K0, K1, K2, and that's K0, K1, K2. But then it just throw away the ones that is not common to the left on the right now. So it's something like if you are Yoruba, you understand what I mean by on right we do Agba for the left, Omash Agba for left. So that's why it threw away his own key 3. Then it's now bringing in missing data for the key 1. Then if you join on the right too, but you say outer, you bring everything. So to introduce missing data on both sides. Are we getting it? I will assume our response is yes. But then today's class is very, very fast. I'm saying I'm very, very fast because what I'm treating today in less than 1 hour here, or a normal day, I should treat it for 2 hours. But then we are almost in the last distance. Any questions so far, please? If you have any question, please ask any of your questions now. Maybe you have a problem with your assignment or anything. Ask them now before we continue with our notebook, before we start operations in Pandas. Any questions? Any questions? Any questions? So
No questions, sir.
this your no questions is scaring me. I am saying you understood everything I explained this morning.
Yes, I'm trying as much to grab as much as I can.
Okay. Okay, operations in Pandas. So here we created our data frame, then printed the head.
That's something on this call.
Head will give us the first 5 rules, 5 rules, but then we don't have up to 5 rules here. But that give us the whole thing. But then if you are using the imported data frame from next class, we start importing data frames and as in CSV file. In fact, we import one in this class. Then you'll be able to understand what this head is doing well, more very better. Let me say more. Let me tab on. So here we have unique. So it's giving us the unique distance for each for column 2. So all the unique ones. But then 444 appears twice. So you just print it out once. So that's the number of unique. This one is n, that's n unique to find number of unique. So we have 3 unique. Then value count. You can see we have value count. So we have 444 appeared twice, 555 appeared once, 666 appeared once. Then we have this. So we want where our column is greater than 2 and column 1 is greater than 2 and column 2 equals to 444. But then it's only one of them. That's that. So you can see it's only one. So we check our distance. Where is greater than 2? So here are the ones that are greater than 2, but then it's only one of the column 2 that is 444. So you can see that there. Then times 2. So we want to multiply everything in our x by 2. So we apply times 2 now. You can see we are applying times 2 on everything in our column 1. So that's how you apply your function on your data frame. So you create a function. For example, I taught us how to create a function in, what was it called now? I taught how to create functions when we're doing Python crash course. So here is where you apply the functions that you've been creating. So here you just do multiply by 2, but then you might want to do something more complicated than just multiply by 2 like that. Then apply length. So we are looking for the length of each of the values in column 3. So this 333 because the numbers there are just 3 numbers there. Then we can find the sum of column 1. So we can delete column 1 actually. So you can see column 1 is gone. You don't even need to put in place. Once you do delete, automatically throw it away. So then we can print out the name of our columns. So we have column 2 and column 3 remaining here. You can print out our indexes. So we start at 0, stop at 4, and step equals 1. Then we have our DF. So there's our data frame here. So sort by column 2. So we want to sort everything by column 2 now. So you see that 444 will come up. Then we have 555 follow. Then we have 666 follow. So to rearrange this, the index will now be 0, 3, 1, 2. So we run this now. You can see this index is now 0, 3, 1, 2. But it did not set in place equals true. So it did not actually replace our distance. Then we check, if you say it's null, it will give you every place where it is null as true. So if you say drop any, that's what we did in our what's it called now? Missing data. So if we drop NE, to drop all the rows that there is NE. But then we have our numpy array here, and we have our missing data introduced here. So we have one missing data here and we have one missing data here. So we fill any with fill. You can see what happened. Everywhere that we have missing data, we have fill there. But then here is our data frame here. So we have df here. So this is our data frame here. We have our data frame created here. So we got it from this that we have here. Then we can create a pivot table. So the values in the pivot table will be D. So the values in our pivot table will be this particular column here. Then the index will be A and B. So we have multiple index. We have index A, that's full, and ba. And we have 1, 1, 2, 2, 3, 3, 1, 1, 2, 2, 1, 1. That's our second index. Then our colon, the colon name will be XY, XY, XY. So we run this now. You can see what we have. So we have XY. You can see the XY appeared for 1 and 2, 1 and 2 like that. So you can see what our pivot table did. But then we could have used group by to achieve what we have used our pivot table to achieve. But then our pivot table can be printed out for our client to see. So maybe you want to group by, want to give a pivot table of maybe divisions, then each of those divisions, the amount they made and the likes like that. So you have to use pivot table for something like that. But then you want to find statistics of each department or something, then you have to go back to group by. Any question? Any question? Any question? Question? Oh. You don't ask question, I will ask question. Okay. If I say group by A, and I said, okay, group by A, if I say, okay, let me just run a code here. If I say, okay, B, okay, if I say df dot group by, oh yeah, now, bit for me now. Okay, group by, I say group by A, and I say dot mean. What will this give me? Anybody? Anybody? You can write your response in the comment section. Before I go to the next notebook, which is the last notebook for this class. And every other name fade away. I'm waiting for our response. I'm waiting for our response. Two? Can't be two now. It can't be just two now. I said go by A, then find the mean. You don't get what I'm saying, you know? That's what I'm saying. You guys don't understand what I've been teaching you guys. I said goodbye. Remember when we were doing goodbye? A is not defined. So this is what it's supposed to give us. I said go by A. Remember when we're doing Google, Microsoft, and Facebook, where we go by companies. Here I go by A. So it's giving me that. So if I say go by B, what would it give me? No for my hand this time around. If I say go by B, what would it give me? Okay, someone is giving a response. 1 give 2, 2 give 3.5. You want that? Nine over 4. You two know math. What about if I say go by C? What would they give me?
Go by C, X we give, that's 8, 9, 3. X we give 3. Then
I should X will give 3. X3, Y3. You are wrong. But then you get the general idea, you get the gist. That's the major thing. So I believe we all understand go by more now. I think we should dwell more on others too. For the end of the class, we'll dwell more. But let's touch on this, our last final notebook for this class. So here we import NumPy and Pandas. So we import our CSV file here. Then get our data frame. Then we, oh, sorry. I just said import okay. How many of us have worked with Excel? Raise up your hand if you have worked with Excel. This way I will know if anybody is listening to me or not. Raise up your hand if you have worked with Excel. There's a function to raise up your hand in Zoom. Okay, Akiyemi O, raise up his hand. Elegbede, let me spell his name. Thomas, have you worked with what's it called before?
yeah.
I believe you have worked with what's it called before too. So moving on from there, so we read our so to read so we have Excel file. You know, you can save your Excel file as a CSV file. So that's what we are doing here. So let me just quickly go back to here. Let me come back here. Then this is our CSV file here. So we open it. So this is what our CSV file has in it. But if we open this CSV file with Excel, you know the way it will draw lines and everything inside it. So that's what we have there. So here now we want to import it. So we use read_CSV to import CSV files. So we save as CSV. So we save as we save our file as CSV instead of the normal XLS file. So to now bring in the Excel file now. So here it is. So read underscore CSV. So we read in the example, then the data frame. This is the data frame here. So we then say CSV.output. That is, if you want to export a CSV file, let's say you've done some data cleaning on this CSV file now, you want to export it. So say to underscore CSV, you know, to bring it in is read underscore CSV. So to export it out is to CSV. So that's what we did here. So that's what we did here. So whenever we say to CSV now, to export it. So for example, let's say we said let me first open the exported CSV now. This is what the exported CSV looks like. ABCD 0123. So let me just do some modifications to it. So let me add a new let me add a new colon to it. So I say df new is equal to df a.
Sorry, how do you do that? Sorry, how do you do that exported CSV now? Like, how do you show those values?
No, I just go back to my document. I have the CSV file opened in the folder I opened here. So when I click on it, it opened it for me. Do you get it?
Oh, yes.
So here now, I want to create a new column. Then I have DFA, then plus DFB. DFB. If I run this now, you know our DF now has a new column. Our DF now has a new column called new. And see our our example.csv here. You know it has just ABCD. But then if I now export this one now, you see what happens. So I exported this. If I come back here and I check my example again, sorry, this is the normal example. Then the example.csv. I check my example.csv. You see there's a new column called new. Do you get it? So it is the actual file that I have in here that I was exporting. So that's what happened there. So we can read in our CSV file, do some modifications to it, then we export here. Do you get it?
Yes, sir.
Okay, let's move on from there to the next thing. So we have read Excel. So we can read an actual Excel file. Notice the extension for Excel, XLSX. So we are reading in Excel file. So this is our Excel file now. Then we can do any modification we want and the likes, and we export our Excel file back. So this is how to export Excel file to Excel too. So we are getting it like that. Then to import our HTML file, I don't believe this thing will still work for us. But then you want to import a HTML file, you can use this read.html. Let me see if it will work actually. I don't know if the website is still live. So it's checking. The website is no longer live. That's why it's not importing it. No table found. So if you only want to import table, so let's go online and look for a website with table. Can someone give me a website with table? Let me look for the website with table in it. Table here too. I need a website that has table. Maybe a website that shows rows and columns of a particular data set or something. I'm looking for a table, but then I can't find any yet. So here is one table here now. So let me copy this URL. Let's see if it will. But then this table it's not a table. It's an image. It's not an actual table. I need a website that has table. I don't have any website in my head that has table now. But then you have a website that has table, you can easily use this. You can easily use this. Then you can import, bring in your table, the first table with this index. But then let's go to FC. Let me check this website. Let me check this website. That's right. In the website with tables. And there's table here now. Why is not telling me there's no table? There's a table here now. Jesus, take your place. Okay, that's imported the table now. Can see this is the table we have here. So this table that we have here now, the first table we have on this page, that's this table. That's what we have here now. Are you getting it? Hello?
Yes, sir.
So you want to import a table from an actual HTML page online. This is how to do it. So you can see I went to that website. I copied the link to the table. My link was not correct because it was giving me error before. And I can see the table you have here is not even that long. But then it imported everything. Notice our table here. You can see you can pick the number of rows you want to see. Example, you can pick 100 now. Then it show you 100 rows. Then you can come here and pick 12. Then show you just 12. Are you getting it? But then if we come to our own table here to import the old table for us, and the old table is actually 562 rows. Are you getting it? So that's then you can now export this thing now. You want to export this to a CSV file now. So this is basically what you just do. Let me just put this up a new colon here. Let me just copy what we have here. Then just paste here. So you can see I'm doing copy and paste myself. So don't be scared to do copy and paste. So you can see our DF, this is our DF, which is this table now. So we want to export DF0. So we have DF0. That's this table alone. So we have DF0. So if we export this and we call it df.csv, for example, let me call it df.csv. If you see here, there's no file called df.csv here. You can see there's no file called df.csv here. But then we'll come here and we'll run this. You come back here now. There's now a df.csv. I can't find it. Can't find df.csv. Okay, it's not here now. You can see there's df.csv here. If I now click on it, you can see showing me all the banks. Are you getting it?
Yes, sir.
So we've created a new CSV file on our system like that. Then we have a SQL here. I don't have SQL installed on my system, so it might not necessarily work. But then I will create an SQLite data frame database here. So I've created one like this in my memory. Then to SQLite, this object has no attribute to SQLite. Oh, DF to SQLite. Sorry, my DF is too big. I mean, my DF is not just a data frame, it's a list. But then let me go and run this DF that I have here. Let me run this DF that I have here. Let me import this DF again here. So I can use that one for my SQLite. So if I run this again now, to work fine. Then I've exported that to my SQLite. I just created a dummy SQLite database on my system now. Most of the time in your office, you'll be working with either MySQL, PostgreSQL, or under database engine like that. But then it's still the same way you will relate with everything. So read underscore SQL. So we are reading an SQL file. Then we are calling our data. Then we are saying our con equals engine. So you can see you set our engine here. But then when you are doing your own, your engine might be an SQLite. I mean, we have set your engine here to be maybe your MySQL table or your Postgres SQL table. So you now run this now. You check your DF now. You can see you imported your data frame here. But then your index has turned into a row here. And that's because when we're doing this thing, we have index here. And that's why our index became a colon on its own here when it entered into our SQLite database. But then we can just delete this colon here. So how do we delete this index colon here? Anybody? How do we delete this index colon? Anybody? Someone should respond. How do we delete that index colon? Don't fall my hand, I beg. Don't fall my hand at all. Because I've mentioned it today and I'll show you where I mentioned it. Don't fall my hand at all. Oh yeah, now anybody, how do we remove that? It's not the delete I taught you. It's not delete I taught you. That's not, it's not remove I taught us. It's delete I taught us. Let me even look for where I taught you. You guys are just following my hand this evening. I don't know why. This one is just the delete I taught you, not remove. Let me even try to remove it to work. I will prove to probably to work. I'm not sure. Because I've never used remove in my life before. Someone has no attribute remove, you can see. But then I thought you go by using the term. Where did I treat itself? I've mentioned it today. I want to show you why I treated it now.
You've passed it, it's up.
Eh?
You've passed it.
Where?
Like up, more up, up.
Not here now. This is the uppermost up of it. I know I've taught
Like
you guys.
DL now.
Now I've taught you guys deleting this thing today. But then I don't know which notebook I treated it. That's a problem. Notebook that I treated is not here. Some operations should be in operations, but then it's not in operations. Open, learning, go
Just
by
pass it again.
where? Where? It's not here now. There's no delete here now. I just want to show you before I do it myself. I just want to show you where it is in our notebook here.
I'll check again.
Delete, delete. It can't be here. I'm pretty sure down. It can't be here. Just to join tables. Goodbye. It could be here, shall. Goodbye. Me. Goodbye. Maximum. Can't describe. It's not here. You're missing the tab. Drop any. No. Voilà, there. Can you submit to never buy? But then I've taught us today. I mean, remember I've mentioned delete today, and I've not taught anybody, not even the students in my physical office yet, anything on Pandas today. So I know it's only in this class I've mentioned delete, but then I can't find it. So please, when you are going through the YouTube video again, you'll find the delete. But then let me just quickly do it so that we won't waste our time. So instead of this, what's it called now? Instead of this remove here, use del. Is it del or delete? Del.
Del.
What's going on? Invalid syntax. Delete is not the correct thing. I know del is the correct thing, but then it's telling me invalid syntax. What's the invalid syntax there? Okay. Deleting sorry, deleting a column in Pandas. Okay, we can drop. I've thought us drop, but there's not drop I want to use here. Deleting I'm talking about. To delete, so we don't need to actually call. Oh, sorry, it was my mistake. So we have, you can see me myself, I made a mistake now. Okay, let me just undo what I just did. So I'll just say del, then we have SQL, then we have index. So we want to delete our index now. Let me comment out this, and I run this. Oh, sorry, SQL underscore data frame, df. You can see it has done that for me now. If I check my SQL df now, SQL underscore df. If I run this now, oh, we already deleted it, so it does not exist again. But then let's re-import it, then run this. You can see it has deleted the index that is here, that deleted it here. So this is how to delete. I've mentioned it today. I guess I was looking for something else. That was my mistake. Okay, this is it here. Actually, this is it here. So I've created it today. Permanently removing a column. No drop will not permanently remove it, but then delete will permanently remove it. For drop to be permanent, you have to say in place equals true. So any questions so far? Because I've exhausted everything I have in stock for us today. Any questions? Any questions?
No, sir.
Are we all in the same alignment that there's no question? But then maybe everybody should go back to YouTube and check this tutorial on Pandas. Then I've done a tutorial on Pandas that is not part of this series of lectures. I've done a separate Pandas tutorial on YouTube. You can check that one too out to get a better understanding of what we did today. So everybody will understand better. So I believe it's a very good place to close the curtain. Yeah, but then next class will be taken by Ola. I've forgotten his name now. Some of my friends. He's a data scientist too. So it's going to be the one taking us introduction to what's it called now? Introduction to data visualization with Matplotlib next week. So let's see how it goes, how we enjoy his class. Maybe you guys will even enjoy his class more than my class. So I'll be seeing you guys on, I'll introduce him actually before the class begins. So I'll be seeing you guys on Friday. Thank you very much for attending today's class. Take care.
Thank you, sir.
And please make sure you do the assignment. I will push the code to the GitHub repo now. So attempt the Pandas assignment, the NumPy assignment, and if you have not done the Python assignment too, attempt it and comment the link. That when you push your response to the GitHub, your GitHub repo, comment the link to the response in the comment section of each of those videos. The video for NumPy, the video for Pandas, the video for Python crash course, so we can know how far everybody has come. So please let's try and do that, because there's no way for me to know you guys understand what I'm doing. You don't try those assignments, and you might think you know it, but then if you don't try your hands on projects like that, you won't have mastered anything at the end of the day. So please do that, and see you guys in the next class. God bless you. Bye-bye.